I'm recording now. Okay, so the challenge, the citizen science project that I picked was from the Zooniverse group. So the Zooniverse group has like so many different projects that you can get involved in, ranging from biology, chemistry, there's languages, there's arts, and of course, being a space guy, I wanted to do a space one. So I picked one here. I'm going to share my screen. Okay, so I picked this one called Planet 4. Okay, Planet 4 is Mars, right? Mars is the fourth planet from the sun, fourth planet out from the sun. And this is a project that is about investigating the surface of Mars, but only at the South Pole. So, and specifically, they're looking at features that look like this. So I'm going to get back to this in a second. But this, there's a lot of pictures like this one that this project is about looking at, and getting people like you and me to go and look at these pictures of the surface of Mars. You can see the scale there. That's about 150 meters in size, and picking out features that are on the surface. And the features we're looking for are these sort of what they call fans and blotches. And what they're caused by. They have a cool little picture here. So ooh. I know, right? You gotta have cool graphics. And just like on Earth, on the South Pole in the winter, you get a seasonal ice cap made of a mixture of different ices, mostly water and carbon dioxide. And as it starts to warm up, stuff that's underneath, ice that's underneath, specifically CO2, starts to sublimate and turn into straight from a solid ice into a gas, and it needs to escape. The gas wants to escape its trapped area under the ice, and it finds a way out through cracks and fissures and stuff, and does these like sort of plumes, poofs up when the pressure is released, it poofs up. And if there is wind, then the dirt and dust that's carried along with it will go downwind and create a fan. And if there's no wind, then it will just sort of land all in an area, and you get a blotch. So you can get these fans and blotches created by gases escaping from ice as the summer comes to the south of Mars. So let's do a couple, and then I'll let you go to it. Oh, see, perfect. So here's a great image. So you look at this right now, and I can say, look, boom, there's a fan right there. Right? At least that's what I think it looks like. So I say, I agree. You agree? Okay, good.
Kind of looks like it.
I say yes. Now I have to mark it. Okay, so I said yes, and I mark it. So they have this thing that I draw, and it's really easy to draw. You drag around.
Isn't that backwards? Oh, I see. It comes out that way and fans that way.
At least that's the way I think it does. It looks like there's other ones down here and here, but I don't know if I can draw them properly. So I'm going to say there's a fan there, maybe created by ice things. Done. And that data was then collected, and the scientists can go take a look at what I just marked. And with this data, they can not only can they learn about how gas escapes and how the breakup of the ice cap changes, but they're also looking at wind patterns, like where the wind is going during the approach of the summer, during the spring season. So it's pretty cool data. Here's another one. It looks like nothing, so I just say no, done. And there you go. There's another image of Mars. I don't see any on there, but there's some cool features.
What are those?
I have no idea. Those are yeah, I don't know. So that's the project. What do you think?
Cool. I'm actually excited to start doing this.
Yeah, and you can do as many as you want.
Woohoo! All right.
Awesome.
All right. And we report back.
Yeah, go do some classifications of blotches and fans, and then we'll see what you think after you're done.
Quick question though. I saw the little progress bar at the bottom, 7% of Mars completed.
Oh,
how many
yeah.
observations would we have to do to complete that bar?
I had a lot. Okay, hold on. Let me. So yeah, there was a progress bar. Here's my, okay, about, is it here? I can't remember where it is. There it is. So 7% complete. There's been
130,000 classifications.
Yeah, so scale that as you will. It's only 10% complete and you have 130,000. So you need 10 times that to
So over 1 million.
finish. And all of these pictures. Okay, everybody, how was that?
That was super fun. It appealed to like my sense of minutia.
Oh yeah?
I found the blotches hard to identify. I wasn't fully sure what I was looking for. And then I got like a field of fans, and then there was a couple that were just kind of blotchy. So I called them blotches. Yeah, there was a couple of photos where I was like, is this a blotch? I don't know if this is a blotch. I'm gonna circle it because
That's what I did. I found one, I had a screen, it was an image that had like 30 blotches on it, I think. They were like circles. And so I'm like, well, I guess those are blotches. And I like marked all of them. It took a little while. Yeah.
Mm-hmm. I had to go back and kind of look at what I was looking for again, because similar problem, like especially when images, it seems like a mix of blotch and fans.
Mm-hmm.
Like, where do you draw the line between a blotch and a fan? That was interesting.
Yeah.
Did you see any of those cool spidery looking?
Yeah.
Yeah. Those
I
things
did
are
not.
awesome. Oh, that's a shame.
I had a
Sorry,
couple.
RC.
One actually really good one that went like, it was like going like all spiderwebby across the entire screen. It looked
nice.
exactly like a river.
And that's kind of what they are. They're channels. And they what happens is the ice forms over top of them, and inside the channels is where the gas starts sublimating out of. So it's like it's where the CO2 deposits in those channels. So normally the ice would have been on top and you'd get fans above it. But the ice goes away and then you see the spider stuff.
Right. Well, I guess you get things like that happening under glaciers on Earth too, with like the meltwater, and then they deposit everything in those little under glacier streams, and you're left with these spider web hump patterns.
Interesting. Oh, I didn't know you could find those on Earth.
Oh yeah.
Now I'm gonna have to
So
find.
is there, pardon my ignorance, is there liquid ice on Mars?
There is, in terms of liquid water.
Or sorry, solid. Yeah, I mean, there
liquid
ice on Mars. Yeah, liquid ice.
You mean water?
So let me re-ask this. So pardon my ignorance. Is there ice on Mars currently?
There's definitely ice on Mars. There's lots of ice. There's seasonal variations to the amount of ice depending on the north and the south and what has winter and which one has summer. But there's definitely lots of ice, and it's both H2O and CO2. And there is a little bit of a cycle. So some of that stuff will sublimate up into the atmosphere during the summer months and then redeposit onto the ice caps in the winter months. So there's lots of ice there. There's even a little bit of evidence of liquid water there under some of those ice caps. But in general, it's just either solid form or gas form.
Well, good.
Good. I was wondering about that. I was thinking, what if like my data isn't right?
No, you're performing the task of looking at hundreds of images alongside of other citizen scientists like us, and then the ones that we mark will be flagged to the scientists, and the scientists will go through them and be like, oh, these people weren't right, and oh, these people were right, and that kind of stuff.
Okay. So we're making their job easier in a sense.
Yeah.
Cool.
Exactly. Good job,
Thanks
everybody.
for showing that project to us, Jesse.
That was fun. Thanks for
You're
that.
welcome, for sure.